Hello, my name is Ryan, and for this assignment we will be exploring the many variables that could possibly have any correlation with rampant criminal activity. We will be importing an SCV file containing data of multiple different cities, as well as 7 separate variables. By training a linear regression model, hopefully we will be able to discover any relationships between crime and these variables. So the data set that we're going to be pulling from has been obtained from this site. It contains crime-related data and education levels of population of different cities. The 7 separate variables in question are total overall reported crime rate per 1 million residents, reported violent crime rate per 100,000 residents, annual police funding in dollars per resident, percentage of people 25 years plus with 4 years of education, high school education, percentage of 16 to 19-year-olds not in high school and not high school graduates, and percentage of 18 to 24-year-olds in college. And the 7th factor is percentage of people 25 years plus with at least 4 years of college. Alright, so the first step I'm going to do is I'm going to mount my Google Drive. I'm going to import the crime CSV into a pandas data frame using the read CSV method, and here I'm just going to display the top 5 rows of the data frame. Next, I'm going to display the shape and summarize statistics of the data frame. So the shape, I'm going to be running this like so. Here it shows that we have 50 rows and 7 columns, so 7 variables and 50 cities that we'll be using for this data frame. And for the statistics, I'm going to be using the describe method to gather the statistics. So count, mean, standard deviation, and so forth for all. Yeah. As for this method right here, the value count method returns all values within our data frame. The drop NA set the false attribute includes the count of missing values, not aka NaN, and within the results, it brings those values into the result. As you can see here, there's no NaN. There's no missing variables in any rows or columns, so that should be good. Now I'll plot the data using the matplot library with at least 2 separate chart types. The first type I'm going to be using is a scatter plot, mapping the annual police funding per resident, money per resident, and the total overall reported crime rate per 1 million residents. I'm going to be using these 2 columns, X and Y. So this one will be the X, and this will be the Y. And I'll plot it like so. As you can see, there's somewhat within this data set, there's somewhat a linear positive correlation. Not a strong one, but there is somewhat a positive correlation, linear correlation within these 2 data sets, with these 2 columns, series. Next, I'll be plotting a line graph. That's my second chart. I'll be using the index, which is cities, and I'll be plotting 5 of these columns. And I will display it like so. Not really much to gather here, to be honest. There's no real patterns. That's okay. Next, I'll split the data into testing and training, validation, and performance measurement. I'll be importing the proper models, the libraries and linear models. I'll start training these data sets using our data frame, test size of 30, and a random state I'll be setting to 33. This basically just seeds all the randomized values here, that they're consistent. Next, I will train a linear regression model using the sklearn library training data. Okay, so I will split it. This will be the x-axis will be the independent variable, annual police funding, and this will be the dependent variable, total over time reported crime rate. X y. And so this is the training, and this is the testing, and then I will fit it. I'll put it into the linear regression model using this function, using this method, and I will use the .fit_func method to basically formulate the best line or the best function to represent the data. Nice. And I'll test the trained model using the testing data and making a prediction. So the y prediction using the x test. These are all predicted y values that potentially may exist using the data that we tested, that we trained our linear data model with. These could potentially exist. And judging from our scatter plot, yeah, it's possible. It's within the range. And now I will plot the line, the linear line, for a visual representation. So it's telling us that the xfit is telling us that this is the best function to represent this data. And as you can see, there's some correlation between the two columns here, somewhat a linear correlation, a positive linear correlation with this data set. We'll check and display the performance of the model with a mean square error. It's outputting a massive number. Usually, if it's the more accurate it is, it's more closer to 0. And in this case, it's very off, so we don't have. It's the scale of the error is pretty big. Anyways, that's all for now. Thank you, and I'll hand it off to my partner to do the rest. Thank you.
Hello, this is Yeganeh. So the second variable we'll be analyzing is x7, which is the people 25 years plus 25 years with at least 4 years of college. We'll be comparing the crime rate against x7. So I'm using these libraries, and then, as always, I'm just importing the CSV file. So we had to draw 2 different graphs using a PLT library here. So the first one is scatter plot, second one is bar plot. So for the first one, I'm just doing plt.scatter, and then the first column that goes in is the x-axis. Second one would be the y-axis. Then setting some descriptive names and labels, and then doing plt.show makes the graph visible to us on the screen. Second one is bar graph. We define some beans and labels, labels for each of the beans. Beans basically, they just mean ranges. Then using pdcod, we divide x7 into different beans, which have their own labels. And then here I'm calculating the average crime rate for each of those beans using a mean method, and again defining my labels and title and plt.show. So and here I'm just training my model. We're using linear regression, importing from sklearn. Yeah, that's the algorithm we're using. So we're just splitting our data set into training and testing sets. then as you can see here, my test size is 20% of the whole data set. And so using model predict, actually before that, we use model.fit, which means we're feeding the training data to the model, and we're having the model make a prediction for us and store, then we store it in this variable here. Then we draw another graph here. Then this value here holds the calculation on how off our model's prediction was based on the actual crime rates. So based on, like, in conclusion, I've noticed that there's no apparent pattern between education level and crime rates. That's the conclusion I've reached.